In this lesson, I'm going to show you how to simplify complex fractions and complex rational expressions. So what is a complex rational expression? Well, it's just a non-simplified rational expression that contains rational expressions within the numerator and or denominator. So it's basically fractions over fractions. So you have like or rational expressions over rational expressions. So you have a rational expression in either the numerator or the denominator or both are rational expressions themselves. All right, so how do you simplify this? It turns out that simplifying complex rational expressions is not really hard actually, and there's a quick and easy way of doing this. And it is multiply both numerator and denominator by the LCD, by the least common denominator of all the rational expressions within the complex rational expression. So you're going to look at all the rational expressions either in numerator and or denominator. You're going to look at all of them, and then you're going to find the LCD of all those little fractions. And then you're going to multiply everything, top and bottom, by the LCD. And after distributing as appropriate, this multiplication will effectively eliminate all the rational expressions within the expression. Okay, so it's going to kill all the little fractions on the top or bottom. And then you're going to be able to simplify as usual. So this is best understood with an example, of course. So let's do some examples first with numbers, and then we'll introduce the variables. The idea is exactly the same though. So here's the first one. So you have 2/3 plus 1, all that over 2 minus a third. Okay. So one way, which is not the easy and quick way, so I'm not going to do it that way, but one way would be to just simplify the top first, then simplify the bottom, and then simplify the fraction as a whole. So you'll be simplifying the top, you'll be simplifying the bottom, and then simplifying the whole thing. So it's like 3 simplifications involved. But if you just do this trick, you save a lot of time and effort. So we're going to look at all the fractions involved, and we're going to find the LCD. So I see a 3. So I see a 3. Look at all the denominators that you see. I see a 3, and that's it. So there's no other fractions besides thirds. So that means the LCD is just going to be 3. That's the only fraction I see. So we're gonna multiply both top and bottom everything by 3, and we're gonna distribute this. Okay. So multiply the whole thing on the top by 3. And similarly, you're going to do the same thing for the bottom. Okay, so you're going to multiply everything by 3, top and bottom. And then when you distribute, if you do this right, all the fractions are going to get cancelled. So you see, you're going to get distributing 3 times 2/3 plus 3 times 1. So distributing like that. And then same thing, distribute for the bottom. 3 times 2 minus 3 times a third. Okay, so you distribute the bottom as well, and then you see these fractions now are going to cancel. 3 cancels with a 3, and these 3 cancels with that 3. And what do you get? You get 2 plus 3 over 6 minus 1. And this simplifies to what this is 5 over 5, which is 1. So the answer is 1. All right. So that's all you have to do. Just multiply by the LCD of all the denominators that you see. In this one, we only had one type of the denominator, namely a 3, so that was just that. But let's do another one where we have two different denominators. Okay, so this one says 4 over 5 plus 1 over, all that over, 4 minus 1/10. Okay, so here we have two different types of the denominators. Here I have 5 and a 10. 5 and 10 appear in the denominators. So what is the LCD of 5 and 10, the least common denominator, if you were looking for that, the least common multiple technically. So the least common multiple of 5 and 10 would be 10, right? The smallest number that contains both as a factor. So that means that we're going to multiply everything on the top and everything on the bottom by 10. So this is going to be 10. So multiply everything on the top by 10. And you multiply everything on the bottom by 10. Okay, now we're going to distribute. So we're going to have 10 times 4/5 plus 10 times 1 is 10. And on the bottom, when you distribute, you have 10 times 4, which is 40. And then 10 times 1/10. Okay, now we're going to simplify this. We're going to cancel a 5 from the 10 and the 5, and we're going to get a 2. So it's like 10 divided by 5, that's 2. And then these cancel. So what are you left with? You're going to be left with 2 times 4, which is 8. And then on bottom, you're left with 40 minus 1. Okay, and what is that? That is 18 over 39. And we should simplify this if we can, and I think we can. You can divide top and bottom by 3. If you divide the top by 3, you get 6. And if you divide the bottom by 3, you get 13. Okay, and that's it. You see that we had a lot of fractions in there, but at no point in time we get our hands dirty with fractions because we just kill them all by doing this trick. So it makes simplifying complex fractions a breeze. We didn't even need a calculator for that, you see? Okay, so if you got that, you should pause the video now and attempt C on your own. Okay, and then we're going to compare notes. Okay, let's do it. So we look at all the different fractions that we see and look at all the different denominators. I see a 4 as a denominator. I see a 6 as a denominator, and I see a 3 as a denominator. So what is the least common multiple of all these fractions? So what is the smallest number that contains all of these numbers, 4, 6, and 3 as a factor? If you say 24, that is a common denominator, but it's not the smallest one. The smallest one is 12. And if you use 24, that's not wrong. It's just that you're not using the most efficient one. So that means when you get to the end of the problem, you're going to have to simplify more, because by not using the smallest one, you will be guaranteed to have to simplify. And the numbers will be bigger as well. So that's not something you want. All right, so let's multiply by 12, top and bottom. Everything gets multiplied by 12, so we're going to have 12 times 1/4 plus 5 over 6. And then you multiply the bottom as well by 12, so 1 plus 2/3. Okay, so then let's see. Distribute. So you're gonna get 12 times a quarter plus 12 times 5/6. All of that over 12 times 1, which is 12, and then 12 times 2/3. Okay, so you can cancel here, divide by 4, that's going to be a 3, and then 12 divided by 6, that's going to be a 2, and then here 12 divided by 3, that's going to be a 4. Okay, so let's write down what we have left. We are left with 3 plus, and then we have here 2 times 5. 2 times 5 is 10. All that over 12 plus, and then you have 4 times 2. 4 times 2 is 8. And then this is what? This is 13 over 20. And that's the answer because we cannot simplify that anymore. 13 and 20 have nothing in common. Okay, so that's the idea of how you simplify complex fractions. Now, when you have variables involved, it's actually still the same process, exactly the same idea. So now we're going to do some with fractions. With variables. Okay, simplify the following complex rational expressions. Okay, so we're going to look at all the fractions that we see, and we're going to find the LCD. So I have one fraction has x squared, and the other one has x as denominator. So what is the least common denominator? Well, it's going to be x squared because the only factor that you see is x, and you always choose the highest power. So it's going to be x squared. So that means we're going to multiply everything, top and bottom, by x squared. So this is going to be x squared times 1 over x squared minus 1, and x squared times 2x minus 2 over x. Okay, so multiply everything by x squared. Now you're going to distribute. So this is going to be x squared times 1 over x squared minus x squared times 1. Distributing here. And then distributing on the bottom, you're going to have 2x cubed, because x squared times 2x is 2x cubed, and then minus x squared times 2 over x. Okay, let me box this thing up into so I wouldn't get it mixed up. Okay, so we continue here. So here, now you see x and x squared cancel. You're going to get just 1. And here you have x squared on the top and x on bottom. So it's like you have x times x, so you're going to cancel one of the x's, and then you're left with only one x. So I can cancel that, and that becomes a 1, or x to the 1, which we never write the exponent to 1, you're just going to write x. So what do we have? We have 1 minus x squared, all that over 2x cubed minus 2x. Okay, that's what we got. And then we have to think whether that is simplified as much as possible. Can we keep going and simplify this a little bit more? Well, we don't know, but we should try. And remember how you simplify rational expressions. All you have to do is factor as much as you can and cancel if there's anything repeated, and that's it. So factor in the top, that's the difference of squares. 1 minus x, 1 plus x. And the bottom, the GCF is 2x. And if I factor out a 2x, what do you get? You're going to get x squared minus 1. Okay, it's not factored as much as possible. We have to factor a little bit more. So the bottom is now a difference of squares. So this is x minus 1, x plus 1. And now you see that there's some repetition here. We can cancel that. But the only one that is actually repeated is the 1 plus x, because 1 plus x is the same as x plus 1. However, 1 minus x is not the same as x minus 1, so I cannot cancel those. So this is something we had run into a long time ago. When you have a difference, the order matters. These are not identical. These are for sums, but not like that. So we're going to have to factor out a minus. And factoring out a minus is going to allow us to reverse the order. So factor out a minus from the top. And now they are identical. Now we can cancel. So now that cancels. Remember, when you cancel, you're not left with a 0, you're left with a 1. So that means the top is actually then negative 1 over 2x. That is the final answer. All right. Okay, now let's do another one. This one says 4 over x plus 1 over y, all that over quantity 2 over y minus 1 over w. So this one has multiple variables, but it's all still done the same way. Look at all the denominators. The denominators that I see are x, y, and w. So what is the LCD of this? This is just going to be the product of all of them, x by w. So then that means we're going to multiply everything on the top by x, y, w, and everything on the bottom by x, y, w as well. So x, y, w, 2 minus y minus 1 over w. Okay? And now we're going to distribute. So this is going to be x, y, w times 4 over x plus x, y, w times 1 over y. All of that over x, y, w times 2 over y minus x, y, w times 1 over w. Okay. Now let's cancel. The x's go in this one. In this one, the y's go. In this one, the y's go. And in that one, the w goes. So what are we left with? On the top, we're left with 4yw and xw. And on the bottom, we're left with 2xw and then minus xy. Okay, and then you should always ask whether is this the end? Is this simplified as much as possible? Are we done? Well, I don't know, but we should if we should try to factor and see if anything cancels. So from the top, you can factor this. You pull out a w, which is common, and then you have 4y plus x, and there's really nothing more that you can do to factor that further. And from the bottom, the x is common, and you have 2w minus y, and there's nothing else you can do to factor that further. And you see that nothing can be cancelled. So that means this was already simplified as much as possible, and you can offer either of these two as the final answer. Both are correct. Okay. So say that's the final answer, or that's the final answer. Both are perfectly good. All right, now we're going to do two more. These two look a little bit more scary, but they're not. They're still same idea, same procedure, same everything. Okay, so what are the denominators that I see? I see x squared minus 4, which factors as x minus 2x plus 2. And I see x minus 2, which cannot be factored any further. And I see x plus 2, which cannot be factored any further either. Okay, so what is the LCD of all these three things? You write down the different factors, remember the process. And you always choose the highest exponent for each of these factors. If there's any exponents other than 1, there's not, so that's it. That is the LCD. Okay, so that means we're going to multiply top and bottom by this. So let's write that out. So this is going to be x minus 2, x plus 2, and then this is 1 over x squared minus 4 plus x over x minus 2, and we multiply the bottom likewise by x minus 2x plus 2, 1 plus 2 over x plus 2. Okay. Now we're going to multiply this. Note that this denominator right here, x squared minus 4, is actually exactly the same thing as this x minus 2x plus 4. This right here is just a factorization of that. So that means they're actually the same. That means when you multiply them, you're actually going to get 1. Okay? X squared minus 4, again, make sure you understand that, is the same thing as x minus 2, x plus 2. So that bottom is exactly the same as this top right here. So everything, if you just replace that with that, both of them are going to cancel. So you're just going to end up with 1. Then when you multiply that one by that one, the x minus 2 is going to cancel. Okay, the x minus 2 is going to cancel, and you're going to be left with x plus 2. Okay, so let's write that down. When you multiply that by that, the x minus 2 cancels, and you're left with x plus 2, but you're also left with that x though. So these cancel, but you're left with both x and the x plus 2. If you want to write that out in a separate piece of paper and see it, this is what is going on. You have x minus 2, x plus 2, and then you're multiplying. This is x squared minus 4, but that is the same thing as x minus 2x plus 2. So you see everything cancels, so you're left with 1. So that's that one. And then for the other one, when you distribute the other one, that's x minus 2, x plus 2, and then I'm multiplying by x, x minus 2. So this x minus 2 cancels, and you're left with what? You're left with x plus 2 times x. You're left with x plus 2 times x. So that's what I wrote, but I changed the order because the order doesn't really matter. X plus 2 times x, or x times x plus 2, same thing. All right, and then on the bottom you have that, so which is x minus 2, x plus 2, and then when you distribute here, you have the x plus 2 cancel, so you're left with the 2, and the x minus 2. And now we need to simplify this as much as we can. Let us see, this is distributing here. This is x squared plus 2x. Follow that over. The FOIL in this, that's x squared minus 4, and you don't really have to FOIL it because that's the same as this, which it is x squared minus 4. And then this is 2x minus 4, distributing that one, 2x minus 4. And then this is putting everything in order, x squared plus 2x plus 1. And on bottom, you have x squared plus 2x minus 8. Okay, and then you ask yourself, can we simplify this anymore? Well, the top, if you factor it, factors as x plus 1, or x plus 1 squared. And the bottom factors as x plus 4, x minus 2. And that's it. That's how you factor that. And you see there's nothing repeated. You cannot factor this any further, and you cannot cancel anything. So that is it. That means you could give the answer like this, because that means the fact that we cannot cancel anything means that this is already simplified. So that's an acceptable answer for that one. Either way is good. So you could say this is the final answer, or you could say this is the final answer. Again, both are simplified, so both are acceptable as the final answer. Okay, now lastly, you should pause the video and attempt this one and see whether you did it right when we compare notes. Okay, let's list all the different denominators that we see. We see x minus 5. We see x plus 5. You cannot factor these any further. We see a 2 and we see a 3. So the LCD of all these is going to be 2 times 3 times x minus 5 times x plus 5, which, simplifying just a little bit, it is 6 x minus 5 x plus 5. Okay? So that is the LCD. So the LCD is this. So we're going to multiply the entire complex fraction, both top and bottom, by this, by the LCD. So this is going to be then 6 times x minus 5x plus 5. And then I'm just going to write one big parenthesis and copy this, copy the numerator. X minus 1 over x minus 5 plus 4 over x plus 5, all that over 6 x minus 5 x plus 5, and then this is 2 over x plus 5, oops, minus 3 over x minus 5. Okay. Now we're going to distribute, okay? So when you distribute and you multiply this by that, the x minus 5 will cancel, and you're going to be left with the 6, the x plus 5, and the 1. And of course, the 1 doesn't do anything. So basically just add 6 and x plus 5. So this is you're going to be left, when you distribute, you're going to be left with 6 times x plus 5. Okay, you have to distribute. You have to multiply like that. Okay, now when you multiply this by that, the x plus 5 are going to cancel. And you're going to be left with what? You're going to be left with 6, x minus 5, and the 4. You're going to be left with 6 times x minus 5 and the 4. And now let's distribute over the bottom. So when you distribute this by that, you're going to be left with, you're going to cancel the x plus 5s, and you're going to be left with 6 x minus 5 times 2. And then when you distribute that times that, you're going to cancel the x minus 5s, and you're going to be left with 6 x plus 5, and that should be a minus because the number, the sign in the middle is a minus. So minus 6x plus 5, and you still have the 3. Okay, now let's continue simplifying. Now we're going to distribute over here. So distribute all of these. So this is going to be 6x plus 30. Distribute that. And then here you have this, combining these two, 6 and 4, you get 24. So it's like, imagine a 24 here in front instead by combining the 6 and the 4. So you have 24x. And then what is 24 times 5? 24, I'm putting that in the calculator. 24 times, oops, 24 times 5, that's 120. Okay, so minus 120, all that over. And then combine these 6 and these 2, that would be a 12. So imagine then a 12 in front, so it would be 12x, and then 12 times 6 is 60. So minus 60. 12 times 5. 12 times 5. 12 times 5 is 60. Okay, and then here, 3 times 6 is 18, so imagine an 18. So this is going to be minus 18x. And what is 18 times 5? 18 times 5 is 90. And you have a minus, so both are going to become minus when you distribute. And now, combine like terms. This is going to be 30x. 30 minus 120 is minus 90. And then on bottom, 12 minus 18x, that would be negative 6x. And negative 60 minus 90, that would be minus 150. And you may simplify this a little bit more. You can, let's say, factor, you have to factor the top and the bottom, see if anything cancels. So factoring out, you can factor out a 30 from the top. So factoring out a 30, that's a GCF. So it will be x minus 3. And from the bottom, you can factor out 6. I think 6 goes into 150. If you factor out a 6, and let's say negative 6, this is going to become x plus 25. Almost done. Now you can cancel a 5. And I'm going to move the minus to the front. So this is going to be minus, sorry, cancel a 6, you're going to end up with 5. 5x minus 3, all that over x plus 25. So you could leave it like that. There's nothing else we can do to simplify this further. Or you could distribute the negative and say this is negative 5x plus 15. You don't have to do this, but you could, and you will not be wrong. So either way, I kind of like offering the answer in factored form. That's simpler. I mean, it looks simpler. But either way, both are